Welcome to Zero Knowledge, a podcast where we explore the latest in blockchain technology and the decentralized web. The show is hosted by me, Anna.
And me, Frederick.
In this week's episode, I sit down with Brandon Ramirez from The Graph to learn about what they're working on, the fast-evolving Layer 1, Layer 2 paradigm, and the emergence of service protocols. Before we start, I have a quick favor to ask. In order to make this show as good as it can be, it would help us to get some feedback from you, our listeners. I added a link in the show notes this week to a short questionnaire. If you're a long-standing listener, or even if you're really new to the show, we would really like to hear from you. Of course, you can also stay in touch with us on Telegram, on Twitter, and through our YouTube channel. So to the new listeners who recently joined us, hi. Be sure to subscribe where you get your podcasts. We share a new episode every week. So looking forward to hearing from you. And now here's our interview with Brandon from The Graph. So today I'm sitting with Brandon Ramirez from The Graph. He's the co-founder and research lead of the project. And today what we're going to be talking about is the concept of Layer 2, Layer 1, what that is exactly, and also where the graph fits into this. So welcome to the show, Brandon.
Hey, Anna. Good to be here.
I have a question for you, kind of like to give us some context of who you are. Kind of give us a little bit of a sense of your background and maybe try to pinpoint the moment that you got really excited about blockchain or about sort of the origin ideas for the graph.
Yeah. So first, my background. My academic background was in electrical engineering, but came up through school in LA and wasn't really interested in working for like many of the defense companies out there, which was the primary kind of funnel for electrical engineers. So I went into the software world, worked for about 5 or 6 years as a product manager at various enterprise companies, startups, and then switched and worked as a software engineer for several years. Well, so my first familiarity with crypto was we briefly stayed in a startup house in Austin back in I want to say it was 2013, 2014. And these guys were going to Y Combinator to start one of the first Bitcoin exchanges. And they were sort of these prototypical techno libertarian, techno anarchists. And at the time I was my interest was piqued, but I didn't feel passionate about the vision that was sort of exciting them. It was really, I think, when I heard about Ethereum and kind of came to the idea of programmable incentives and the implications of having a fully decentralized internet application stack, applications that never die, that can outlive their creators. That idea really fascinated me and I think was sort of what drew me into the space.
What was your first, was the graph your first project in blockchain, or have you done something else with Ethereum?
Yeah, so this is getting actually to the origin story of the company a little bit. Yaniv, Giannis, and I were working on a developer tool startup they were working on it for about a year. I kind of joined for the last few months doing some software engineering. And we were kind of finding over lunches that instead of talking about our business, which is what we should have been talking about, we were just talking about crypto. Every single lunch, talking about the implications, trying to understand new projects that were publishing papers at the time, because this was, in 2017, a lot, all the white papers are dropping. And we knew we wanted to get closer to the space. And so we actually shut down the startup we were working on at the time, and we just started a full stack web agency and decided that would be the best way to kind of get our feet wet, pivot with our current experience of doing application engineering, but then also start targeting our services towards blockchain companies. And that was we had a 6-month period where we were sort of getting our feet wet that way before we started the graph.
Were you still over in LA at this time?
No, I move all over the place. So I did school in LA, but I've lived in Seattle, Austin, and at this point I was in San Francisco, I believe, or maybe the East Bay.
So you had this web development agency. Where's that pivot moment where you decide you're going to start a business or start a project yourself?
Yeah. So it was kind of a long drawn out process, to be honest. So I think Yaniv had the initial vision for the graph towards the end of 2017, maybe even before we started the agency. And it was it was more of the 5-10 year vision of the graph, right? He kind of had this vision of all these data sets that are public, that are, operating on blockchains or kind of public storage layers and are completely interoperable, right? So this is one of the things that really fascinated us early on, was this idea of blockchains as this interoperability layer, in contrast to today where APIs are sort of the interoperability layer. So we started having these conversations, and I didn't see an obvious like A to Z path on like how to get there. And then it was through the course of doing some of our consulting work, we realized that there was a real short-term problem that projects were facing, which was actually how do you build an application directly on top of the blockchain? And what I mean by that is the blockchain provides like a pretty low-level interface for getting data out of it. And so what projects were having to do is they were having to do like what's called ETL to put their data into like a database, and then that's what would drive their applications.
What is ETL?
So ETL stands for extract, transform, load.
Okay.
And it can be done in batch. It can be done in like streaming jobs. But it's typically how you get like data from multiple disparate sources or, sources that aren't fit to your domain into like another data warehouse or database.
Got it. So you were seeing these sort of individual projects having to create that themselves or do it themselves.
Correct. And so we were on a project early on. There was a number of teams on the project, a number of different consulting teams, I think 3 or 4. So we were responsible for building like a dashboard based on like a GraphQL API. There was an entire other team that, their entire job was basically just taking data out of Ethereum and putting it into like a Postgres database. Yeah. So when we saw that, these projects that were trying to build applications on top of Ethereum were, willing to spend, by our estimates, $100,000 to $200,000, if not more, on just putting data into a database, that was kind of when we developed conviction that like, hey, there might be a real business here. There might be a path to get to this longer term vision that, Yaniv had started talking about, towards the end of 2017.
Interesting.
So it was actually over the holidays, I think, that Yaniv and Giannis started working on a prototype. I came back from like the Christmas break, and they had this like really simple like working example of like a GraphQL server that was written in Go and was basically listening to events on the blockchain, putting them into, I can't remember if it was a database or even just like a local cache, and then letting you query the data through like a GraphQL API. So in early 2018, we decided that we wanted to dedicate some time to pursue the idea full time. We took a few months break from our consulting work. Yaniv and Giannis continued working on the demo. I wrote the first version of our white paper. And in, I believe, March or April, we raised venture capital to work on the graph.
That's cool. Actually, it's something I wanted to talk to you about in general, which is like the funding of some of these projects. But I want to hold that because I want to first better understand the graph and kind of what it's used for. You just mentioned this GraphQL server. This is my question actually about the graph. Is there like in the general kind of Web2 stack or computer, like just general computer science, are there concepts like the graph? And is this trying to take those equivalents and turn it into like a Web3 product? This is something I've always sort of assumed about the graph, but I'm not entirely clear if that's the case.
Yeah, the answer is yes and no. So in a traditional Web2 stack, you would have an API server. Traditionally, for a long time, that was like a REST API. And in the last few years, a technology called GraphQL has kind of gained prominence for a whole host of reasons that we can talk about later. When you're building a traditional application in Web2, usually you already have a database. So, it could be a NoSQL database. Commonly, it's, a SQL database like Postgres. And so you're writing your application data into that database. And then that database is taking care of things like indexing and making sure that that data is efficient to query through your API layer. So there is an analog for the graph today in the sense that, Web2 applications have an API layer, but blockchain by its nature has created a whole set of other requirements, which is like now we need to be able to index this data that's on this decentralized layer where block reorgs can happen arbitrarily. And now we have chains that have finality, but for most applications building on Ethereum today, like that's a concern that didn't exist for Web 2.
When you say, so like the whole concept of the graph, is it built for Ethereum specifically? Is it built for any smart contract platform? Is it built for ETH2? What's it actually meant for?
So our goals for the graph are to be multi-blockchain. I mean, we want it to be wherever dApp developers are. So we started with ETH 1.0 because that's where we felt the most developer traction was for decentralized applications. But we think in the future, there's going to be a lot more interoperability between blockchains, both at the layer 1 and kind of at the service layer where we exist.
Do you see the graph then being like, is it tooling? Is it tooling for dApps? Is it one of these like necessary components for any sort of application to run on these smart contract platforms or these layer 1 platforms? Is that kind of your thinking around the project?
Yeah, I think it's a combination, right? There's definitely a developer tools component to it. We're giving, we have clients that developers can run, CLIs to like help their workflow, to write a subgraph and deploy it. But primarily the graph is, this service layer. So it's the decentralized infrastructure that developers can deploy their subgraphs to and query. Where typically I would think of developer tools as being something that's more like local to like a developer's machine, but maybe doesn't have a running infrastructure component to it.
And what is it built out of? Like, is this a standalone software stack, or is it I'm trying to figure out, is it a smart contract project? Like what is it?
Yeah. So today the primary part of the graph is the graph node, which is a indexing server that's built in Rust. And so it listens to events on the blockchain and it puts them into a store, which today for us is Postgres. In the decentralized network, which we're planning on launching next year, the graph's application logic for the protocol rules will be implemented as smart contracts. But then there will still be these nodes that are the graph nodes that speak the language of the protocol and will be running as a separate service layer.
And those would then be decentralized.
And those will be decentralized.
Because what is it right now? There's like, when you said there's a node built in Rust, is it like just within the project itself, there's a few people running these nodes? It's not spread out. There's no incentive for anyone to run these nodes outside of it.
Right. Yeah. So this is some good, I guess, history on kind of how we approached our product development roadmap.
Yeah.
So the first thing that we wanted to do was build a node and just open source it to solve this problem for developers. So we did that, I believe, in July of 2018. And it was like maybe a month before ETH Berlin. And so we just got a lot of really great feedback on just like, hey, here's this tool. We think it's useful. You can run it yourself and it solves this set of problems. Towards the end of 2018, what we were realizing was that even though it made it, orders of magnitude easier to solve this problem, it still required you to kind of run a database. It required you to like have some knowledge around Docker. It still wasn't a trivial setup to, set up this indexing server and GraphQL API. In early 2019, earlier this year, we launched the hosted service, which is a centralized service where we're operating graph nodes on developers' behalves. Many of our developers have chosen to switch over to this just to reduce their operational, overhead. But you can still, go to GitHub, download the graph node software today and just run it for yourself in your own infrastructure. What we don't have yet is a decentralized network where anyone can participate in running a graph node, and an end user can query any graph node based on what's going to provide the highest quality of service to them. And that's what we're working on launching next year.
So the first iteration, you did actually imagine like other participants running nodes. Who would those participants have been in that case? Are they like the dApp developers? Is it like who would have run them?
Yeah. So in the first iteration where we just open sourced the indexing server, it would just be projects running it for themselves in their own environments, basically.
Is it the chain operators? Is it like the actual layer 1 chain, or would it be the layer 2 dApp operators who would actually use something like this? Or would they all?
Yeah, so that's a good question. So when we launched the open source version of the graph node, we were primarily targeting it at dApp developers that wanted to run this infrastructure for themselves in their own centralized part of their application stack. So this is maybe good background on like what developers were doing before the graph. There were basically like one of two kind of major options. Like one, you could have these applications index the data locally on the user's machine. So you could efficiently query, data in the application once the user's machine is like synced. And so I believe apps like Augur and Aragon took this approach. The benefit is that the app stays fully decentralized, but the The downside is obviously degraded user experience. The other approach is the one that like CryptoKitties took, for example, where the core application logic is running on the blockchain and is decentralized, but they run these centralized indexing servers where they're, loading the data into their own database, and then all the user experiences that people are interacting with are actually interacting with their centralized infrastructure.
Oh, wow.
And so when we launched the Graph node, we were basically trying to make that second pattern easier for people, although you could still run it locally on the user's machine if you wanted. But the reason that we're, pushing forward to this decentralized network is that we still think that pattern is suboptimal, right? Like I wouldn't even call that a layer, quote unquote, in the decentralized application stack, because it's really just centralized services operating, adjacent to the decentralized application stack.
Got it. And so originally you started sort of open source, anyone could have a node. Then you started to offer hosted services, which centralizes it, but that's not where you're stopping. Mm-hmm. Have you had any pushback for actually even creating a hosted version?
We did early on, and I think it was, more towards like, I guess when some of the fervor of 2017 still hadn't like worn off. I think there was a lot of like residual like optimism, and I think part of it was supported by the marketing around these projects that like Web3 was something that was just going to happen tomorrow, that it was like a few weeks away of just like really hardcore development, and that the entire application stack was going to just be decentralized. And then I think what you saw in 2018 is that 2018 was a tough year for a lot of investors and a lot of teams as well. And I think it was kind of a reality check that like, hey, if we want to build something that's going to be useful to users today, we need to be pragmatic. I think a lot of, what we focus on now is kind of being very vocal about our commitment to pushing forward to the fully decentralized network, but that in the short term, we want to offer developers and end users, a consumer grade user experience and give them the ability to build performant web applications. We've
touched on that idea of like the trade-off between decentralization and maybe like performance or speed of development. We've definitely talked about that quite a bit. And I find it fascinating because I think the idea of decentralization is so beautiful, but at the same time, in practice, you see some of the complications. And there is this thinking that you do have to sometimes be pragmatic and decide like, well, we want to get from point A to point B, but like, how are we going to do that most effectively? And it may not be starting decentralized.
Yeah, I think there's a few different dimensions of it, right? When people talk about centralization and decentralization. So there's, architectural decentralization, which comes with trade-offs, right? Right now for layer one blockchains, for example, that means a lot of redundancy. It means, not the kind of performance that you would expect from like a consumer grade application. And then there's like organizational and political decentralization, where there's no obvious shelling point of like a clear leader that's, dictating a strategy top down, and kind of moving a organization in lockstep towards a specific goal. I think at different stages in a project, I think both can be appropriate, but I think it's just a matter of timing. I think it's understanding like what stage you're at. I think very early in a project's life, it's advantageous to be able to move quickly, and sort of, be aligned instead of having to like for every change to the protocol or project, submit a proposal, get buy-in from the community, talk about it on Twitter. I think that's something that's more appropriate as a project's hit a certain level of maturity.
Fair enough. Yeah. So you mentioned sort of these two dimensions, and you've just sort of talked about the trade-offs in the second one, the social one, but what about the trade-offs in that architectural one? What does that look like?
Yeah. So I think this is actually, we're starting to get into like the distinction between the category of projects that the graph fits in versus, for example, a layer one blockchain. I think for a layer one, because it is the foundational platform upon which many other services and applications are being built, people have a much higher bar set early on to kind of weight decentralization and trustlessness over, for example, performance. In these service protocols, the security model is a little bit different, right? And it's unique to each project, although there's commonalities. So take the graph, for example. We're indexing data that's on the layer one blockchain, and we're presenting that to users in a way that's efficient. We're not the source of truth for any data. We are not the source of truth for any state transitions on the underlying blockchain. So we can weight things like performance a little bit higher than decentralization in the early days of our protocol without degrading the core utility of what we're offering to end users and developers.
Cool. I think what we should do right now is define the layers. And the reason I want to do that is, a lot of what I want to speak about in the next section of this podcast is layer 1, layer 2, how they interact, what the landscape looked like, what it looks like now. This is something I don't feel that we've really properly covered ever on the podcast. So I'm really happy to have you walk me through this. This is really cool. And then I want to go back to these trade-offs that we just outlined, because I think that would be really cool to see it in that context. But let's talk about the layers in blockchain.
Sure.
We had Dan Bonet on recently, and he actually defined 4 layers of the blockchain. And I'm going to share those with you. I don't know if you'll agree with them. It's just sort of one perspective, but he saw layer 1 as consensus. He put layer 1.5 as computation/EVM. Layer 2 was the DApp, or applications like stablecoins, like the mechanisms of stablecoins. And then he had layer 3, which was the user-facing wallets and sort of actually a lot of the user-facing stuff. So in that, I don't know what you think of that layering. Does that make some sense to you, or?
Yeah, the layers make sense. I think a lot of different people are going to have different opinions on like what should be called, the bottom of the stack. Like 0.5 seems somewhat arbitrary.
I don't know if he actually called it layer 1.5, but he put it between layer 1 and layer 2. So
right.
Yeah.
I can say that colloquially, when people generally talk about layer 1 and layer 2, usually they're talking about layer 1 as a blockchain. Sometimes that also extends to include storage layers like IPFS. And then layer 2 is usually a scalability solution that is somewhat general purpose and extends the capabilities of the layer 1. So you can think of like state channels, plasma, side channels, roll-up solutions. Those would all kind of fit into the category of layer 2 when people are speaking colloquially. Like this is, if you're talking to someone at a conference, they're like, oh yeah, this is a layer 2 solution for XYZ. In terms of the actual, technical layers, without like advocating a specific numbering, I would say maybe I think of, the bottom layer as being like P2P networking. Maybe a layer above that, I would say, is things like DHTs and like content address storage, right? So this is like what IPFS uses, but it's also what Ethereum uses. Above that, I would put consensus, which enables like the smart contract execution. And then I would put the layer 2 scaling solutions. And then somewhere above there, you have these service protocols, which is the category that the graph fits into, these kind of trust minimized services. And further up the stack, you get the actual decentralized applications.
Where would you put something like a stablecoin then? Where does that live?
I don't know if stablecoin in my mind occupies its own layer in the stack. To me, that's like an application that's running on this application stack that we're building, right? So if you take something like, DAI, for example, it's composed of many of these different layers, right? So you have smart contracts that are running at the consensus layer that are running on the blockchain, but then you also have, off-chain services maybe that are supporting, that are submitting transactions to the blockchain. There's, very clearly a need for auxiliary services in order to make this useful for users at the presentational layer. So I just wouldn't think of it as being, I think of those as being the types of applications that we are trying to support by building this layered infrastructure.
Thank you so much, by the way, for just like also sharing that colloquial definition. I do hear it. I've always heard layer 2 thrown around just to define kind of anything that isn't the consensus level too. Like I've just sort of heard like and everything else is layer 2.
Yeah. And I totally do the same thing, right? Like that's certainly another valid colloquialism. Like people will say the graph is a layer 2, protocol for querying blockchain data. But yeah, I would say that's very colloquial rather than trying to be, precise.
Like is layer 1 and layer 2 maybe an outdated term actually, or the way that we use it colloquially, is it sort of not really representative anymore?
Yeah, I think that's a good question. So when people talk about layering, a lot of times they're inspired by like the Osi model, which is like kind of, the way that the kind of
A
old school.
phone works. Yeah.
Well, it's the internet application stack, right? Like, so you have all these networking protocols that sit upon other protocols, and the idea is that each layer in the protocol is only aware of the layer below it, and that the layer below it abstracts away any other layers below it, right? So if I'm at like at the transport layer in the protocol stack, like I don't know anything about like the physical like link layer, right? Like there's several layers in between that sort of abstract that away from me. Now in blockchain and like Web3, we don't really mean that in the same exact way, right? Like, so if you're building on a layer 2 solution, like let's say you're building on top of, state channels, you're building on top of, Plasma, that doesn't preclude you from also interacting directly with the layer 1 blockchain. So that makes it kind of hard for example, to call something that sits on top of Plasma a layer 3, because in like the old model, that would mean, okay, it's only interacting with the layer below it.
But it isn't. It's actually going to be interacting with like multiple parts of those 2 layers underneath
exactly.
it.
And if you think of like the decentralized storage layers also being its own layer, oftentimes you might be interacting with the blockchain, but also the decentralized storage layer. So yeah, you're kind of always interacting at different levels in the stack.
I mean, I guess eventually we're going to have to retire those terms anyway. I mean, there can't only be 2.
Right.
I mean, or you just start getting into the 5s and 6s, but I have a feeling like no one wants to build themselves as like a layer 6 solution.
Yeah.
Somehow it just doesn't have that same ring.
Well, crypto's kind of a space built on memes. So maybe layer 1 and layer 2 will just be, really powerful memes that just carry forward.
So maybe let's talk a little bit about what these service protocols are and how they connect to all of these layers. What's a service protocol exactly? I know you've mentioned in the past, but maybe we can talk a little bit more about it.
Mm-hmm. Yeah, so a good analog, if you're familiar with the Web2 space, is like kind of like microservices, right? So there was this trend in Web2 where originally we were building software as these giant monoliths, and we started decomposing software into kind of more purpose-specific services called microservices that, could be unbundled from the larger application. And so service protocols in the Web3 space are sort of an analog of that. So there are these more domain-specific building blocks that kind of sits atop the more generalized foundation that's provided by like blockchain layer 1 and layer 2 solutions.
You kind of mentioned IPFS is living still on sort of the layer 1. So would you put that under the category of service protocol?
I wouldn't put IPFS there because it's this very general platform that we're building on, right? So like in Web 2, you're building, even though you're building with microservices, you're always using some combination of compute and storage, right? And so in the Web 3 space, I think of your compute as being, the blockchain or smart contracts, and then your storage being something like IPFS.
Okay, so it's so core to the entire mechanism, you wouldn't necessarily call it a service protocol.
Right, and it's extremely general, right? So, you get into a service protocol like the graph, and like we're far more specific in what we're doing, right? We're helping you with a specific type of computation, which is doing the job of indexing and then efficiently querying the data that we've indexed from the chain. Another protocol that fits into this category is LivePeer. So they're, doing a very domain-specific task, which is the transcoding of video, right? So it's not a general purpose computation that they're doing. It's, fit for a particular application domain.
Who else would you put in that category? What other groups?
So I would put projects like NewCipher into this category, Keep, projects like Golem, and where Golem, even though they were, kind of initially targeting this generalized compute, where they've started as this, domain-specific problem of, I believe graphics rendering, I think is their first use case.
Do you have sort of a specific domain that you are also focused on, or is it more of a generalized solution with the graph? Because the graph sounds like quite usable by lots of things.
It's quite general. It's certainly quite general in the sense that a broad set of applications and services need or can get benefit out of the services provided by the graph. I guess when I say that it's more specific, I mean in the nature of the computation, right? Like we're not a generalized compute platform. We are a platform that helps you with a very specific set of problems and tasks that you're trying to solve.
Got it. Do you think, I mean, in sort of the multi-chain universe where you see like all these different platforms and blockchains operating together, I've heard this idea of having different chains be focused on specific services, like, for example, a hosting only blockchain, which I think we're going to also see emerge with something like Filecoin, but like having, hosting, having, I forget what the other, computation, having like all these different ones. Could you imagine the graph then living alone? I know, not that you're constructing it that way now, but could you imagine that concept being a standalone blockchain eventually?
This is something we're watching pretty closely. I'm not sure I have like a dogmatic position on how the future will play out. I think even in a world of multi-blockchain or multiple shards, I think it's clear that there's network effects around some things being on the same chain. And the security model for moving stuff between chains is still not as strong as if something is just on the same chain, right? Like if you're relying on a bridge or some other way of moving an asset between chains. And another, challenge, I guess, for projects that want to launch their own chain is that regardless of whether they go a proof of stake route or a proof of work route, they need to secure that chain. And that can be difficult to do for like a nascent project. So this is a space we're watching closely. But for now, we're kind of focused on, Ethereum and supporting multiple blockchains, but our smart contract logic would run on a chain like Ethereum.
Okay, back to the service protocols. I'm trying to figure out how they actually fit in with these other layers or with the stack. Like, would I run, like, say, right now you mentioned you're kind of hosting for other projects, but like in that first iteration where everyone would run a node, would I then run a node for each one of the service protocols? Like, how would each project have to participate in these service protocols in order to use them? This is sort of unclear to me.
So that's a great question. And this sort of gets to our vision for Web3, or at least the part of the vision that excites us, which is this new model of users interacting with applications where they're paying for their incremental use of the services they rely on for those applications. And so what I mean by that is instead of, today where like, a user pays a centralized company and then the company kind of indirectly pays for all these services and then the services provide utility to the user in the future will just directly interact and exchange value with these services in exchange for getting utility. Now, what the dApp developer does in this model is they deploy logic to these services that the user can then depend on.
And the services would be running, like it wouldn't be that everyone deploying would need to run their own node. The nodes are basically deployed and it is an existing thing that you can tap into, and the security or the mechanism is already taken care of by this decentralized network. It's not that like, I'm thinking of it like a building block you have to download and incorporate, which I realize is not in any way the way it works, but I'm trying to sort of figure out how they interact.
A good way to think about these protocols, maybe in contrast to like layer one, is that we're designing like markets, right? And so there's these decentralized, networks of node providers that are competing in a marketplace, and the end users do need to be able to interact with that marketplace, but they don't need to be able to run the entire node software themselves. So the model's much more akin to like a light client model in like traditional like layer one blockchains, where if you're in the future, if you're interacting with the graph, you will need to have a client on the end user's machine that can speak the language of the protocol, at least to interact and exchange value and data with people in the decentralized market.
But it could be very light. It could be a light client, not a full client.
Yes, it can be. Our goal is for these things to be very light. Mm-hmm. And actually a good way to think about it in our protocol, and I think this applies generally to at least a handful of protocols in this space, is you can almost think of like the end user and the service providers in the market both having like their own kind of algorithmic trading engines that are interacting with each other in real time to like kind of do price discovery and figure out what service providers to interact with and at what price and what parameters. And that's like a big part of the design space here as well. To make this a reality for end users, obviously there's things that need to develop in the ecosystem as well. So we need, the proliferation of state channel wallets. We need better UX for signing transactions and for state channel wallets. Like this wouldn't work if every time the, automated negotiator or trading engine wanted to make a transaction, it needed to prompt the user for like to click a button. So in the interim, when we launch the network, as we're planning to do next year, we'll have actually like a gateway that abstracts some of this from end users so that they can hit the gateway instead of having to have this, state channel wallet and client running locally on the end user's machine.
From there, like you sort of mentioned this marketplace. Can you tell me a little bit more about like what that really looks like?
So a big challenge for protocol designers that are working in this space, specifically with these service protocols, is designing a efficient marketplace. So this is actually something that I'm working with other folks in a service protocols working group, folks from NewCipher, LivePeer, so on, to kind of discuss these, shared challenges that, each project in this space has. But there's a handful of commonalities here. So one is, a service discovery layer, and how do you handle service discovery? So that's like a core function of a marketplace, is that even though it's decentralized, there needs to be some logically centralized place where to go and find service providers.
Yeah.
Assuming that there's many, many service providers, you need to figure out ways to narrow down the set to the ones that can provide the highest quality of service to you or that you want to interact with. There could be things like, rating the performance or, having like local reputation for these service providers so that, like, hey, if this one's done well for me in the past, I interact with it again in the future. You need things like price discovery. So you need, it's not enough to have many participants in the market. You need information to flow in such a way that like prices actually reach an equilibrium that, that's efficient. Another shared concern that we're actually talking about in an upcoming session is, how do you subsidize useful work on the network? How do you define useful work in a way that, can't be spoofed? We're discussing things like how do you, use the work token to get Sybil resistance and economic security in a model where work is coordinated almost completely off chain.
But that leads to another question I had, which was about like, what is a token in this context? Where does it, like, it's not entirely clear for me how payments or how the utility tokens of these service protocols work in tandem. Cause I don't know. Do you imagine every dApp having these tokens as well? Like, how does that, this is super interesting to me because this gets to the core of how I don't fully understand how some of these projects actually fund themselves or plan on funding themselves or how there's a market exactly and like how other actors are supposed to interact with them.
Yeah, so you mentioned utility tokens. That's one model that a lot of projects and like dApps raised on early on, where the idea was that if the token was useful to do something in the dApp, it would be used as kind of a medium of exchange, and that would sort of accrue value to the token and to the network. This approach has fallen somewhat out of favor in recent years for many reasons, not the least of which is that it imposes undue friction on end users if they have to hold a token of some other project, especially given the amount of volatility that we've seen in token prices, where
Totally.
Now we're imposing this kind of quote unquote balance sheet risk on end users. So the approach that many projects, including the Graph, have moved to is called the work token model. And the idea here is that only the service providers need to interact with the token. So service providers stake a deposit of Graph tokens or, the native token for, the respective protocol, and that entitles them to do work in the network. And so these things accrue value according to like the present value calculation. It's very similar to how taxi cab medallions accrued value in regulated taxi markets in cities like New York and elsewhere.
I actually don't know how those worked, but
yeah. So that's okay. I can talk about that. Yeah.
Go a little deeper.
let's see what I can do from memory. So at some point, regulators in New York City, this is going back several decades, decided that I believe the impetus was that there were too many cars and taxis on the road in general, and they wanted to limit that. And so they came up with a model of tradable licenses called taxi cab medallions. And this is pretty unique when you can think of business licenses in other businesses, right? Like if you become a lawyer or if you become a hairstylist, that's something that's kind of assigned to you, but you don't think of being able to trade that. Mm-hmm. But in the taxi cab markets, you could actually trade these licenses called medallions. And so you sort of had a not fully competitive marketplace. So the profits that could be earned in the taxi cab markets by cab drivers were what we would call in economics supernormal profits, right? Like they were profits above and beyond what we would expect in a fully competitive, efficient market. Now, the question is, like, if you have all these cab drivers that are earning these, extra, profits on top of like what we would expect, what does that do to the value of the taxi cab medallion? And the answer is that those profits are capitalized into the value of the medallions according to a discounted cash flow analysis or like present value calculation. And those medallions actually become capital assets that have value of their own.
Do they increase in value as this market progresses?
Yeah, so they increased dramatically in value over the years, partly due to speculation, but also, partly due to like the intrinsic value of the medallions.
And so do you have the idea then of taking this model and putting it into the service protocol world or these marketplaces?
Correct. Yes, exactly. So these service protocols, many of them, if not all of them, kind of adopt this model into the crypto economic space where, similar to the tradable licenses that you had with the taxi cab medallions, now service providers can stake a deposit of tokens, and that gives them permission to do work in the network. Now, what becomes challenging for a lot of protocols like the graph is that for reasons of efficiency and performance, the coordination of work happens off-chain in a sort of organic, self-organizing manner, right? Like there's no top-down controller that says, hey, you have this many tokens, so you get to do this much work. Actually, early versions of some of these protocols like LivePeer, they did work this way as like sort of their first proof of concept because there were so few service providers in the network that they could just have work allocated on-chain. But since we're moving, for performance and scalability reasons, we're moving all this work to be coordinated off-chain, now we have to come up with new techniques to still have the tokens have this same fundamental property of like permitting to do work in the network, but without this top-down control.
And when you say the service providers themselves would stake it, like going back to like that interaction with the dApps, do they have to have some connection to the tokens on the service protocol levels? Like, do they have to own them? Do they have to work with them? Is there any interaction there? Or is it all happening within this like self-defined marketplace that's separate from anything else?
Right. So in the same way that you pay for a cab, with US dollars, despite the cab driver having to own a taxi medallion, we would expect that for most of these protocols, including the graph, you would pay in your sort of medium of exchange token of choice, whether it's DAI or ETH, and then only the service providers need to interact with graph tokens.
Got it. Is there any reflection here in like the way that the MKR holders like do all the governance and voting and stuff like that, and it's separate from DAI? Or do you think that that's a completely different metaphor, different construction?
No, I think that's a reasonable metaphor, and there's definitely similarities to Maker in the sense that you have this token that's kind of more designed for sophisticated, operators of the protocol, and then you have a separate token that's more designed for the average user to use. Right? You saw the same thing with like the Libra Association, where they had the Libra investment token, but then they also had the Libra currency, which is what would be has the properties that you would expect from something that's being interacted with by all end users, namely like stability. For protocols like the graph, we have our work token, which is designed for the service providers in the network. And you could imagine us having a separate token for exchange, and you have seen some projects do something similar. But for us, we just see value in kind of adopting the currencies that people are already using in the ecosystem, like DAI, like ETH.
So this definitely brings me to another question I had a little earlier and I didn't get a chance to ask, which is like, does the graph have a token? Which I assume now is yes.
Yes. So the graph will have a token at launch when we launch the decentralized network, and it will be a work token.
Got it. Is there also in this work token, are there any governance components to it? Could you actually vote on the way the protocol is developed in any way using this stuff, or is it not at all in that category?
Yeah, this is a great question. It starts to get into pretty philosophical territory. Obviously, there's a lot of analogs here between like the debates that we've had at layer one around like on-chain governance versus off-chain governance. Do you, do in-protocol upgrades, or do you upgrade through hard forks? And I think this isn't something where I would expect every project in our category is going to come up with the same answer. So I can offer you sort of my opinion, which is that I think in the first few years of these protocols, it's very likely that in-protocol upgrades through governance will be necessary, and that the work token will play a role in that process. One of my goals as a protocol designer is to minimize the surface area of governance as quickly as possible, and eventually maybe even be able to throw away the key altogether. And that's a lot easier said than done, because when we're designing these systems, we kind of have these qualitative designs, which are like, what are the various incentives for the different roles? How do these different building blocks flow together? How does information flow in the system? But then there's also a lot of quantitative design decisions, right? Like, what's the specific inflation rate that you set? What is the percent cut that a curator gets, for rewards? What is the slope of your bonding curve, right? And it's very difficult to imagine that prior to launching the network, you're going to set all these things in an optimal way. So like one of our future goals as a research team is to model and simulate the dynamics of our system and the dynamics of the protocol design, but then also after we launch to kind of, figure out how well do those models track reality, and like where are areas where we think we would maybe one day be able to relegate the setting of a parameter to maybe an algorithmic decision rather than something that is set through governance.
You just mentioned this term roles. What are roles in the graph?
The way that we've kind of approached the protocol design process is first to define the technical system design. And so this is very akin to how you would design like a traditional Web2 system, right? Like, what are all the building blocks that need to function in order for the thing to do the job that we've set out to do? And so that's sort of binary, right? Like, it either works or it doesn't work. Now, once you have that technical system design, we can't think of these things as all being controlled by a centralized actor anymore. So we need to think about who's going to do all these different functions. And those kind of map to roles in our protocol. And so in the graph, the primary roles are the indexers. So these are the ones that are indexing the data and responding to queries. And the end users, the ones that are issuing the queries via the dApps that they're using. And then also the developers, the ones that define how the indexing jobs take place that the indexers do. Now, often what will happen is when you define these first sets of roles and then sets of incentives, you'll realize that you need secondary roles to kind of support the mechanisms of the primary roles, right? So
do you almost need you need somebody to check in on the indexers or check in on the end user or something like that, make sure it's all happening correctly? Exactly. And so that's where we end up with these secondary roles. And so like when the network launches next year, we'll have a role of like a fisherman, for example, which is doing exactly what you described, checking in on the work that's performed by the indexers. We chose early on to use like a market mechanism for like efficiently matching end users with indexers. But in support of having an efficient market where there's, good market discovery, we also have a curator role. And so that's like a secondary role that I think of as supporting the primary roles in the network. These roles and everything that you've defined here, I'm imagining there's like a very complex incentives structure. I don't know if we can go into it in big depth here on the podcast, because maybe it's better to like write this out on a blackboard or see it. Do you have actually a resource where people can really see how these roles are defined and like what the incentives are for each of them?
Yeah, so we actually just published a blog post a couple weeks ago.
Perfect.
That provides a very readable version of this. We previously had some of this in like previous white papers and like a spec, but the blog post is probably like the most approachable way to kind of get up to speed on the current version of our protocol decisions, as well, including the roles.
In our talk so far, we've sort of heard about the origin story of the graph, and we've heard about the current state of the graph. We've heard about the service protocol group and some of the plans, but what is the future for the graph? What's your next step?
Yeah, so there's a few things coming up in the next year that we're really excited about. Obviously, as you mentioned, we're launching the decentralized network, which is going to be the first version of the protocol where anyone can come in and operate a graph node and participate and compete in the market to provide the service of indexing and querying data. There's a couple things we're actually working on ahead of that I think make that even more impactful. So one of those is we're adding multi-blockchain support. And the other one that I want to talk about a little bit is we're also adding support for what's called subgraph composition. And what this means is that you'll actually be able to build subgraphs that can reference other subgraphs in their data model. And so this is starting to get into like what we saw as being, the sort of master vision for the graph, back when we started, was really getting to the point where blockchains and Web3 was acting as like a data interoperability layer. So the way that we see users building apps in the future is that it'll be much more of a remix culture, than it is today, where you rebuild everything from scratch from the top to the bottom. You might see that, hey, there's a couple protocols out there already that do a little bit of what I need, and here's some subgraphs for them that kind of, reference one another. And maybe all I need to do is build a new subgraph that references the first two subgraphs and covers this little, bit of functionality that's described on chain in a new smart contract. And so I think that combination of having this, composition on a public decentralized protocol is really powerful.
Cool. Are there any specific chains that you're already thinking of working with? Or when you say multi-chain compatibility, in order to do that, do you actually have to change anything? Do you have to work with those teams? How does that work?
Yeah, so there's definitely a bunch of projects we're looking at, talking to, Cosmos, Polkadot, Tezos, others are on our radar. Things we're looking for are traction with dApps, in terms of defining, what chains we aim to support first. And then also, of course, grants, which some projects have approached us about, just so that they can have this as utility to their ecosystem as well. Especially when you talk about like block explorer like scenarios where, to support a good block explorer, you need to be able to index the data on like the underlying layer one chain and present it to users in a way that's useful.
Well, listen, I want to wish you a lot of luck with the coming work and the coming launch and everything. But before we sign off, I do want to ask you a question about your logo and your designer, because you have some of the most beautiful swag t-shirts out there. And it seems like there's a reference in a lot of your graphics to, what was it called? Monument Valley, that video game? Or Escher paintings or something like that?
Oh, I don't know. You're probably looking even deeper than I am. So when we did the mood board for the design, which was done by Carl, who's our brilliant designer on the team, the initial impetus was Space Aztec.
Ooh.
And that's just sort of just evolved over the last couple of years, and that's sort of the various designs and characters and landscapes that you see in our product and like blog posts
Cool.
today.
Well, it's really beautiful the way that sort of comes across. Yeah, so thanks again for helping me navigate this sort of layer question. I think if there's a takeaway for me, like one big takeaway from this, it's to rethink the way we think of those landscapes and to realize like there's certain projects that won't necessarily fit into these layers, but are still incredibly important and needed in the ecosystem.
Yeah, this stuff is still evolving, and so kind of we're learning right alongside the rest of the community.
Cool.
But I'm happy to be on and talk about this with you guys.
Yeah. So anyway, I guess thanks again for coming. And to our listeners, thanks for listening.